Welcome to CW 1.6. Today we're going to continue our study of quadratics and word problems. So right here, it says, here's our figure 2.8, football situation. When a football is kicked, the nearest defensive player is 6 feet from the point of impact with the kicker's foot. The height of the punted ball is modeled here. So you imagine the ball's flight. So it's going to be right here. X is the ball's horizontal distance in feet from the point of impact with the kicker's foot. So part A, what is the max height of the punt and how far from the point of impact does it occur? So I want all of you to highlight maximum. Whenever you see this word maximum, remember we talked about last time, this is going to indicate find the vertex. So for part A, we could just use the vertex formula. We know the vertex formula is going to be negative b over 2a. And again, that would generate the x value of your vertex. So if we were to plug it in, we could just write negative 1.18 over 2 times negative 0.01. Plug that in your calculator, and we're going to get 59, which is the x value. And we plug in 59, and then we're going to get 36.81 for the y value. Right, so we could go through all of that, and we can answer the question. This is what is the max height of the punt? So if we could write 36.81 feet is the max height. And I'll write it occurs at x equals 59 feet. So that'd be the algebraic way of doing it. However, I want to show you how your calculator will do this. So here's my HP prime. I'm going to go to apps, function, and I typed in the equation here, so you can do that on yours as well. I'm going to plot it. So I made my graph already nice, as you can see. I can reset it so I can kind of show you how to make yours like that. Let's say yours looks something like this. That's fine. All you got to do is zoom out with your fingers until it looks like something you want to work with. So right here, I'm just going to pinch and zoom until I can see the whole graph. And yeah, that looks pretty good. Now, to find the height, I'm just going to tap at the vertex. You can see I'm kind of estimating right there. Then go to Menu, Function. I'm going to hit Extremum, that's number 7. And right there, 59, 36.81. And notice how that's the same thing I said earlier. Let's go back to the worksheet. For part B, it says, how far must the player who is 6 feet from the kicker's point of impact reach to block the punt? So if you imagine you're this dude right here, you're trying to figure out how high do I need to jump to block right there. So essentially we're saying if x equals 6, what does y equal? So of course we could just plug it in, but again, I want to show you how your calculator can do this. So we come back here, we're going to hit go to. It says enter the value to which to jump. I want to jump to 6. Now you'll notice that it looks like nothing happened. This is kind of a weird thing. You have to tap menu and then it kind of reveals it. It says 8.72. So I can go back. Oh, sorry, it's the wrong one. Now I know why. I'll write 8.72, which does actually match our picture they gave us right there. And I can say 8.72 feet here. Okay, part C. If the ball is not blocked, how far down the field will it go before hitting the ground? So that's kind of like saying, imagine this thing keeps going. Where does it hit over here? So that's an x-intercept. And for part D, it says graph, so I'll kind of combine it together. For pre-calc, and pretty much all the pre-calc teachers have you do this, we're going to draw a box, and let's just sketch what the picture looks like. So I see that. I'm just going to do a quick sketch of that. Something like this. We're looking for this x-intercept. So to do that, let's go to our calculator. You have to tap near the one you want. So I'm going to tap near the right x-intercept, menu, function, and number 4 is root. That's the one you want. And notice how it says 119.67. That's what we want. So I write this in, 119.67 comma 0. And that is the answer to the question, 119.67 feet. Okay, so that's using our calculator. The next two we're going to do by hand. So questions like this, oftentimes you can kind of think of the answer, but it's important for you to know how to do it algebraically. Okay, so let's go through it. Among all pairs of numbers, the difference is 10. So let's write x minus y is 10. Find a pair whose product is as small as possible. What is the minimum product? So again, you see this word minimum. Anytime you see maximum, highlight that. We're going to have to find a vertex. So in the back of your mind, you're thinking, okay, vertex. Now from here, it says the product. So the product of two numbers is just x times y. We're trying to minimize that. So look at what we have here. We have these two equations. Let's just put them together. You can solve for x or y here. It doesn't really matter. I'll just solve for x. Seems a little bit easier. X should equal y plus 10. And I'm going to plug that in right there. So now my product is going to be y times y plus 10. No, I do that because now I have a quadratic. That's y squared plus 10y. And if I have a quadratic, I can find the vertex. Let's do negative b over 2a. So that's going to be negative 10 over 2, which is negative 5. Now it's important to understand that this number is the x value. But remember, that's like a figurative x value, not the literal x. So even though we used x earlier, that's not the same thing. Think of it more as the input. So if you look at this function here, the input is this y part. So what you just found is the y in terms of our original variables here. So if it's less complicated, we could have used a and b as well. So now we have the y. So we could find x. We just got to plug it back in. So let's look right here. X is y plus 10. So if y is negative 5, x must be 5. So those are two numbers. The question is the minimum product. So multiply them together. Get negative 25. That's your min product. Now notice the way I did it. That's kind of just intuitive, right? Because remember I said like you got to find the vertex. So you actually could have just done it the other way too. Like in algebra 2b, you might have just done this. You found negative 5. Let's keep going. Negative 5, comma. Plug it in right here. That's going to be 25 minus 50, which is negative 25. So notice right there, that's your min product as well. So you could also find the vertex, right? Because that's what we said earlier. I'm just showing you there are like more logical ways to think about it as well. Let's do one more. You have 100 yards of fencing to enclose a rectangular region. So I'll just draw a rectangle like this. We'll call this the width, length, width, length. Find the dimensions that maximize. So there we go, we see maximize. So again, this is a vertex question. Find the max area. So they give you a couple key facts. You have 100 yards here. So we know that the perimeter is when you add everything. That's 2L plus 2W. So 100 must equal 2L plus 2W, which means 50 must equal L plus W. Now our goal is to maximize area, and area we know to be length times width. So let's put these two things together. Again, you can solve for any variable, it doesn't really matter. I'll just pick W, but again, it doesn't matter. So W is 50 minus L. I'm going to plug that in over there. So L times 50 minus L. And again, we have our quadratic. That's negative L squared plus 50L. Let's find our vertex. So vertex is going to be negative b over 2a. That's negative 50 over negative 2, which is 25. Now remember, this is your x value, or the input. So in this case, that's your length. We just found 25 is the length. So if you want, you can just plug it back in to find the whole thing. 25 comma. If you plug in 25 to this equation right here, you would get 625. And again, this would be like the standard vertex way. We'd say that's our max area. So I write therefore 625, what's our unit? Yards squared. Right, so we could do it that way. Or we could just kind of use common sense. If L is 25, we know that the width is 50 minus L. So the width is also 25. So multiply that together, 625 yards squared is our answer. Okay, so that's it. So let's work on some practice problems.